Hi, and welcome to the video on deep learning and neural networks. So firstly, what exactly is deep learning? Well, let's take a look at the power of deep learning. Now, firstly, machine learning has been around for decades, even though it's only recently become very popular. Now, what brought about the data science revolution was the simultaneous increase of computer power, cheap data storage, cloud computing, and most importantly, very high-level developed software and tools and programming languages that made deep learning or machine learning very much accessible to the masses of statistics students, mathematical students, computer science majors, economics majors. Anyone who can understand high-level maths and some basic computer programming could take control or make use of deep learning now. And around 2010 is when we sort of reached a bottleneck on performance of many of the traditional machine learning models, things like logistic regressions, SVM. All of those things were sort of capping out or maxing out on their abilities with complicated data. Now, what changed? Deep learning came on the scene, and deep learning just ravaged all of those benchmarks and scored tremendous scores even beating human level performance. So you can see it right here in this chart. Error rates on the ImageNet Visual Recognition Challenge in 2014 to 2015, the machine learning algorithms using deep learning surpassed human level accuracy. So what accounted for deep learning's performance in this arena? Well, machine learning algorithms didn't work well on very complex nonlinear data. Deep learning was able to achieve this, as you can see in this first point here, by having these deep, complicated networks that could pick up this nonlinear relationships. And deep learning solved this and ushered in a revolution in AI and computer vision. So now we can do such amazing things that we didn't think possible 10 years ago. So it took our models from, yeah, that's pretty nice, to something that's, wow, a human can do that. And you can do this so quickly. You can do a lot of impressive tasks on automated ways so much faster with deep learning computer vision networks. So what exactly is deep learning and neural networks? Now let's take a look at this. So neural networks, you can think of it as a black box brain that takes inputs and gives an output. So you can imagine this feeding an image into some sort of complex model here and tells you it's a dog, similarly for a gorilla. So it's different and a lot better than most traditional machine learning models because, as I said before, it learns non-linear mappings to produce far more accurate output classification results. So this is how a very basic neural network looks like. We have input nodes here. Remember, this is our same input data that I showed you before. This can represent things like income, age, sex, or in a computer vision world, this will be pixel 1, pixel 2, etc. Now, this is the layers here that are important here. These hidden layers are basically trained and they have different weights that are multiplied by the input values here. And they combine all of these different weights here to give different outputs. So one output doesn't matter. So these are the layers, as I said. We have the input layer, the hidden layer, and the output layer. All deep learning networks have a similar architecture. And these are some examples here, very high-level examples of what it can output given some input data here. So how do we generate a prediction? As I said, you can have something, say, representing feather color. You can describe a color here, or give the color values as input. You can give the weight of the bird, and it outputs the species and the sex of the bird. So that's pretty awesome. So this is what a real neural network example looks like. You can have multiple hidden layers, and that's what makes it deep. The number of layers here refer to the deepness of a neural network, and that's what deep learning is about. We have all these inputs here and all these output layers here. So it looks relatively simple. This is a computer vision example here. We have our input image here going through our hidden layers here, and it gives a final output right here, being 4. So that's awesome. This is a handwritten digit, by the way. So what is deep learning? So now I refer to the deep before, deep being the number of hidden layers, and that's exactly what I say here. You can look at this architecture here. So it's another one for a computer vision application here. You can see it learns different features as we go through the deepness of the network, or the deeper layers, I should say. And now there's a good point to note that deeper isn't always better. You can have a lot of problems, especially in training a deep network. So it's also going to learn maybe something that's too complicated in a way, so it overfits on the training data. Overfitting is something we'll discuss later on, but yeah, that's what it is here. Deep refers to the number of hidden layers. That's what deep learning is. So now let's talk about training neural networks. So let's talk a bit about the training process of neural networks. So I'm going to talk this through, and you can try to follow by reading the points, but imagine we have our training data here. Remember, training data is our human labeled images, or for example, we'll use images in this case. So what we do is we input one image or a batch of images to this neural network here. And then it'll give us some output here, because what we do is we initialize some random values, some random weight values here. We can have different ways we can set these random values, but this, for now, consider it's all random values. So obviously, if you feed some image or images here, you're going to get output data that is obviously wrong. But how wrong is it? That's what we use something called a loss function to do. We put a value on our loss, so it can be something like mean squared error or a different type of thing, basically scoring how bad it is from the target, the correct label. And then what we do, we use something with backpropagation to perform the mini batch gradient descent. So what that does, basically based on the loss, we update or change these weights here to now compensate, to lower the loss function here. So the next time we send these images again, we hope to get lower loss here. And that's essentially, each time we do that for a batch of data, it's called an iteration. And until we complete it, it's called an epoch. So that's what we're doing training. So we keep sending these batches over and over and over. And once we finish, that's an epoch that we've completed. And we should have some now decent weights that are lowering this loss constantly. And the lower the loss we have, the more accurate our model becomes. That's what loss measures. Remember, loss measures inaccurate you are. So by lowering the loss, you're getting more and more accurate. So that's why we have to do large number of epochs. And that's why neural networks take a while to train. So this is a graphical illustration of the training process here. So remember I said we have our input data. This is our neural network here, or hidden layers, if you want to consider it there, because that's where our weight values are. We have the output predictions. We have the loss function, which compares the predictions with the true targets here. We have our optimizer, so that's the backpropagation algorithm that gives the new weights here, and the new weights are then fed back into the layer here. So we update the weights of these values here in the hidden nodes, and then we send the image again. So we keep doing this cycle over and over. So what is backpropagation? So backpropagation is a pretty cool algorithm here. So as I said, we calculate what it does. We have the loss here. So then it feeds the loss back into the network here. That's why it's called backpropagation. And it uses that to calculate the gradients now of the hidden nodes here. So we change the gradients being the weights here, and we just feed it down the network here. And then it just updates. So now the weights are in the direction, set in the direction to lower the loss in the next batch. Okay. So what have we learned here? We've learned what is deep learning and what makes it special, what are neural networks and how it is structured, their architecture. And we have seen a high-level view of the training process of neural networks. So now let's move on to the introduction to convolutional neural networks in our next video. Thank you.